Assalamualaikum students, in this lecture we will be revising properties of quadrilaterals. What are the quadrilaterals? Quadrilaterals are actually four-sided polygons. The polygons, any polygon with four sides is called quadrilateral. There are so many types of the quadrilateral, and these sides are mentioned in your book. This page number 270 of your book is very important. If you will go through this page, there is a table which has been given to you, and all the properties of the quadrilaterals have been explained on this page. There are many quadrilaterals: rectangle, square, parallelogram, rhombus, trapezium, and kite, and the property of every quadrilateral is mentioned in this page. First we will discuss rectangle. What is rectangle? Rectangle is a quadrilateral in which every angle is of 90 degrees. Every angle is of 90 degrees. But only, it's mentioned over here, there are two pairs of parallel sides. Opposite sides are equal in length. All sides are not equal in length, but only opposite sides are equal in length. If we will come to the square, there are two pairs of parallel sides. Again, it is similar to rectangle. Every angle is of 90 degrees, but the difference is, there is a difference. Again, every angle is of 90 degrees, but the difference is that all four sides are equal in length. All four sides are equal in length. Over here only, opposite sides are equal in length. In rectangle, every angle is of 90 degrees. In square, again, every angle is of 90 degrees. But in rectangle, opposite sides are equal in length, whereas all four sides are equal in length in square. Now we'll come to the rhombus. What is rhombus? Rhombus is somewhat similar to square. How? That all four sides of the rhombus are equal in length. Over here, look at this. All four sides are equal in length, but there is a difference. There isn't any angle of 90 degrees. All four sides are equal in length, same property. Are equal, but there isn't any right angle. And what about parallelogram? In parallelogram, again, its property is similar to rectangle. One property is similar to rectangle, that is, opposite sides are equal in length. But again, there isn't any 90-degree angle. Now, if you will look at these four shapes, rectangle, square, parallelogram, and rhombuses, they share some properties. Like rectangle and square, they share the property that every angle is of 90 degrees. Similarly, parallelogram and rhombus share the property that there isn't any angle of 90 degrees. Square and rhombus share the property that all four sides are equal. Square and rhombus are similar, just like the way that all four sides are equal in length. You can say that rhombus is the tilted shape of square and the parallelogram is the tilted shape of rectangle. In rectangle, opposite sides are equal in length. In parallelogram, again, opposite sides are equal in length, but there isn't any angle of 90 degrees in parallelogram. Now we'll come to the interior angles and the properties of diagonals of these sheets. What are the interior angles? Interior angles are the angles which are formed by the two adjacent sides of any closed shape. So interior angles of a rectangle, all the four angles are right angle. We have discussed it before that all the interior angles of a rectangle are of 90 degrees. Again, all interior angles of square are also of 90 degrees. Then what about parallelogram? As we know that there isn't any angle of 90 degree in parallelogram, but we know that opposite sides are equal. Opposite sides are equal in length and they are parallel to each other. Look at this. This is a parallelogram. These two sides are parallel to each other. If it is AC is parallel to BD and AB is parallel to CD. And these two sides are also equal in length. They are not only parallel to each other, but they are also equal in length. AC is equal to BD. If they are equal in length, it means that their angles is also same. Opposite angles of the parallelogram are also equal. And in rhombus, all four sides of the same length, so the opposite angles are also equal. Look at the figure. ADC is equal to ABC. ADC is equal to ABC. A, B, C and D. In parallelogram and rhombus, opposite angles are equal to each other. Over here, angle B is equal to angle C. Similarly, angle A is equal to angle D. Same is the case with rhombus. Angle B is equal to angle D, and angle A over here is equal to angle C. The opposite angles of parallelogram and rhombus are equal, whereas all the angles of rectangle and square are of 90 degree. Now we'll come to the diagonals. First of all, you should know that what are the diagonals actually. A diagonal is actually a straight line joining two opposite corners of any shape. Let's suppose this is a rectangle A, B, C, D. These are the two A and D are the two opposite corners. If we are joining them by a straight line, this straight line is called diagonal. And there are some properties of the diagonals. The two diagonals of the rectangle are equal in length. So AD is equal to BC. The two diagonals of the square are also equal in length. Now it's very important over here. If the diagonal is the line of symmetry, it is dividing the interior angle into two equal halves. Like over here, the diagonal of the rectangle is not the line of symmetry. We know that. But in square, the diagonal is the line of symmetry, so it is dividing the angle into two equal halves. And the diagonals bisect each other at 90 degrees. You should remember that the diagonals of the square, rhombus and kite, we'll discuss kite further. The diagonals of these shapes bisect each other at 90 degrees. The point where they are bisecting each other, if you will see the angle which is being formed over here, it is of 90 degrees. Now we'll discuss trapezium. What is trapezium? Trapezium is also a quadrilateral, but the property of trapezium is that there is only at least one parallel of parallel sides. Over here you can see that AB is parallel to CD. If there is at least one pair of parallel side, the quadrilateral is called trapezium. And the last figure is kite. The first property of kite is that the opposite sides may be parallel. Look at this. If this is A, B, C and D, we can say that AB is parallel to CD and BC is parallel to AD. And the adjacent sides are equal. Like the adjacent side of AB is BC, AB is equal to BC. Similarly, AD is equal to CD. Their adjacent sides are equal in length. It's mentioned over here. There are two pairs of equal adjacent sides. Now, if you will look at the diagonal of the kite, you will see that this diagonal is the line of symmetry. So, it means that this diagonal is dividing the angle B and angle D into two equal halves. But this diagonal is not the line of symmetry, so it is not dividing the angle into two equal halves. Only one diagonal which runs through this from B to D is the diagonal which is dividing the angle B and angle D into two equal halves, and the diagonal over here cut each other at right angle. So we can conclude that there are three shapes: square, rhombus and kite, in which the diagonals cut each other at right angle and their diagonals bisect the interior angle. In kite, only one diagonal bisects the interior angle, and that is the diagonal which is the line of symmetry of kite. Now we can do the questions which have been given to us in the task. Question number 1 is objective, and I think that if you have gone through the properties of the quadrilaterals, you can easily do these questions. Part A, name any two figures in which the diagonals cut each other at right angle. I have explained it to you that there are three figures: rhombus, squares and kite, in which the diagonals cut each other at right angle. So you can name any two figures. Part B is name the figure which have two pair of parallel sides. Two pairs of parallel sides, and we know that rectangle have two pairs of parallel sides. Square has also two pairs of parallel sides. Rhombus, you can name any two, and parallelogram. All these shapes have two pairs of parallel sides. Part C, name the figure that has two pair of equal adjacent side. We have done this right now before this task, that there is a figure which has two pairs of adjacent side, and this pair is actually kite. Look at this. We are doing part D. A, B, C and D. AB is equal in length to AC, and the adjacent side is AC. The adjacent side of BD is CD, and these two are equal in length. So the answer of part D is kite. Part E is name the figure that have all four right angles. It's very easy. You can do it yourself. Part F is the sum of angles of a quadrilateral is 360 degree. As the sum of the interior angles of the triangle is 180 degree, the sum of the interior angles of a quadrilateral is always 360 degree. Now we'll do question number 2, part A. A rectangle has been given to us, and in the rectangle we can see that, let's suppose we can name it as Z. The triangle ABC, in triangle ABC, AZ and BZ are equal in length. Dash notations are mentioned. It means that they are equal in length, and it means that their base angles are also equal. So angle X is equal to Y. 3y minus 20, the value of an angle is given to you. I think it's 3y minus 20. Sorry, it's 3y minus 28. We can say that these are the vertically opposite angles over here. If this is 3y minus 28, this angle is also of 3y minus 28. Angle Z is equal to 3y minus 28. So in the triangle X, Y and Z, there are three angles. We can say that X plus Y plus Z equals to 180 degree, the sum of the interior angles of a triangle. We know that the value of Z is 3y minus 28. Angle Y is equal to angle X. These are the base angles of the isosceles triangle. So instead of X, we can write Y. So Y plus 3y minus 28 equals to 180 degree. By solving this equation, you can easily find out the value of Y, and once you have found out the value of Y, it is similar to angle X. Why? Because these are the base angles of an isosceles triangle. So I think you can easily find out angle X and angle Y. Now we'll discuss part B. A rectangle is given to you, and you have to find out two missing angles, angle X and angle Y. Over here, see, we know that in rectangle the opposite sides are parallel to each other. CD is parallel to AB and BC is parallel to AD. You can see that over here Z is being formed. So it shows that alternate angles are formed over here. So y is equal to 79. Alternate angles. You can use the property of alternate angles. So if y equals to 79, now we have to find out the value of x. As we know that it's a rectangle ADC. ADC equals to 90 degree. One of the part of the 90 degree is 79. You can easily find out the value of x. That would be 90 minus 79. Next is a kite. The kite, a diagonal has been drawn over here. And we know that the adjacent sides of the kite are equal in length. The dash notations have been shown over here. Let us suppose we can name it as A, B, C, D. In triangle A, B, C, angle A is equal to angle C. Why? Because it's an isosceles triangle and these are the base angles. So if angle A is equal to 35, we can say that angle C is also equal to 35. Now we can find out the value of angle X over here. That would be X is X plus 35 equals to 180 degree. The sum of interior angles of the triangle ABC. You can solve this equation to find out the value of x, and for the triangle ADC you have to find out the value of y. Over here you can see that AD is equal to CD. The dash notations are over here. So the base angles over here, if one angle is y, this one should also be y. So in triangle ADC, y plus 78 equals to 180 degree. Sum of the interior angles of triangle ADC. You can easily find out the value of y from here. I have formed the equation and I think that you can easily solve the equation as you